Did it just cut out?
Oh, can you hear me?
Okay, yes, no.
Okay, so sorry about that. I just have not used this in a little bit. So it is actually, grab my pen. So it's n factorial over r factorial times n minus r factorial. So that's 3 factorial over 2 factorial times 3 minus 2 is just 1 factorial. So 3 factorial means 3 times 2 times 1 over 2 factorial, which is 2 times 1. So these cancel out, meaning that there are 3 possibilities.
Okay. But so so th- that's I understand that because we've never really worked with factorials before. So how does it like work when it be 3 factorial becomes 3 times 2 times 1?
Factorial is a mathematical operation, so if I had something like 7 factorial, that would mean 7 times 6 times 5 times 4 times 3 times 2 times 1.
Oh, so it always goes down to 1?
Always goes down to 1. So 100 factorial is 100 times 99 times all the way down to
Okay.
1.
And is it possible to have a negative factorial?
No,
Okay, so there would never be a negative factorial.
no.
Okay. Yeah. So then it just cancels out. Okay, so that makes more sense, a lot more sense, because I was seeing him doing that like 7 times 6 times 5 times 4 times 3, and I was really confused.
Okay,
Okay. Um, yeah.
good.
Yeah, I think so.
Okay, so that tells you how many things should be in the sample space. The key here I also want to mention is the fact that this is a grouping, which is why it's a combination. And whenever you have a combination, order is not important.
Okay.
That's why we do the whole like um, AB is the same as BA because they're grouped together as just A and B. So they mean the same thing.
So in that case, it would be combination because the order
Order,
doesn't matter.
the order doesn't matter, and we're doing a grouping. So it's a combination.
Okay, and they gave combinate. They were having you decide if it was a combination or a um
Permutation.
permutation.
Permutation order matters. So
Permutation.
a permutation is like when people are running in the race, who's going to come in first, second, third. If a group of people are running a race, the person who comes in first cannot be the same person who comes in second. So order matters.
Okay, so that makes sense. Okay.
All right, you ready to look at the next one?
Yes.
Okay. So it says Paige rolls a number cube 64 times. The number 4 comes up 14 times and the number 3 comes up 6 times. Round to the nearest whole percent. What is the experimental probability of getting a 3 or a 4?
Yeah.
Okay, so experimental means just that, not theoretically, but experimentally. So there were 64 times that they rolled the die. Is that correct?
Yes. Also, excuse me, I can't see your screen, I don't think, if
Oh
that's
gosh, I'm sorry. I wish we
it's okay.
let's fix that. Can you see it now?
Yes, now it's loading right now, probably still loading. Yes, now I can.
Okay, you good?
Yes.
Okay, so first of all, let's say 3 or 4. In mathematics, the word or means to add. So we're going to add these probabilities together. Experimental means based on these 64 rolls that were made with the die, correct?
Yes.
So out of those 64 rolls, that was the total possible outcomes. How many of them were threes?
Okay. Ooh. Okay.
How many were threes?
Um, page rolling. So number cubed goes up to 6. So
Right. No, look at this. Look at my screen. Let's read it
okay.
again. Paige rolls her number cube dice 64 times. The number 4 comes up 14 times, and the number 3 comes up 6 times.
Oh, so we just add them.
No,
One, two,
no. We're first looking at the probability of 3. Then we are going to add it to the probability of 4. But what is the experimental probability of 3?
experimental.
How many times did the number 3 come up in these 64 rolls?
6 times.
6 times. And then how many times did it come up? How many times did the number 4 come up in this roll?
14 times.
So that's 20 out of 64. So what percentage is that? What's the probability? It says to round to the nearest whole percent.
That would be 31%.
31%. So do you understand where the 6 over 64 and the 14 over 64 came from?
Yes.
Okay, and the key here is we're using the experimental probability.
And how many types of probabilities? There's experimental, theoretical, and
That's it.
Okay.
It's either experimental it's either experimental or theoretical.
Okay.
Good?
Yes.
Okay. So on this next question here, it says 4 swimmers, Danielle, Cameron, Brandon, and Amy compete in a relay race for the first race of the year. Danielle begins the relay. For the other 3 swimmers can swim in any order. What is the sample space of this event? So here's the sample space, okay?
Okay.
Of the other 3 swimmers.
Except for Daniela.
Daniela, because she's going first, no matter what. It says after the first race, it's determined that Camille is first. And so it says, what is the sample space of the remaining, what is the sample space A, or what subset of A of the sample space represents the complement of the event in which Camille is the final swimmer? All right, so Danielle we know is not included, so Danielle's our first swimmer, correct?
Yes.
Yes, okay. So if Camille, it wants the complement. So what we want are all of the choices where Camille is not last, because she's our strongest swimmer. Camille is going to be the final swimmer. So going over to our sample space, in the first example here, where is Camille swimming?
First.
Well, she's second. Remember, Danielle is first. So here on this one, Camille is second. What about this one?
Wait, are you?
What about this one here, CAB?
Oh, she's second also because,
Right. And what about the next one?
fourth.
So we don't want to include that one because here she is fourth, correct?
Yes. And she can't be fourth.
She can't be fourth. Okay, so here, where is she in the race here?
On BCA,
Yes.
third,
And on the next one?
third,
And on this one?
fourth, so you would get rid of it, right?
Right. So this is your subset.
Okay. And by count, is that just
It
that's
means the opposite. So instead of saying Camille is the final swimmer, we say Camille is not the final swimmer.
oh, so okay.
So in all these examples here, Camille is not the final swimmer.
Okay.
Does that make sense?
Yes.
Okay. Any questions so far? Anything I didn't?
No, I don't think so.
Okay. So here it says a dartboard consists of a circle inscribed in a square. The area of the circle is 25 pi, and the area of the square is 100 units squared. It says Megan randomly shoots a dart at the square. Assuming the dart lands within the square, what is the probability that the dart will land with a probability the dart lands within the dart board? Round to the nearest percent. So what that means is the dart board area
25 times pi. 25 pi.
divided by
100.
yeah.
So the area of the square. Okay, that makes sense.
So you're taking that area of your circle and you're dividing it by the area of the square.
Okay, and
So your area of your circle was 25 pi and you're dividing it by 100.
yeah, I got 78.5.
Correct.
Okay, that makes sense.
All right. Next. It says Mariah is randomly choosing 3 books to read from 5 mystery books, 7 biographies, and 8 science fiction books. Now here it says, what is the complement of Mariah choosing 3 mystery books? Remember what I said. What do you do when you're going to take the complement? It's opposite. So how would you write that?
Is the complement of...
The complement would mean Mariah does what?
She does not take 3.
Right. She does not choose 3 mystery books.
Okay.
That's the complement.
Okay.
And you could also say does not choose like all mysteries. That would also be a complement because she's choosing 3 books. Do you know what I mean?
3 books,
So,
one of them can be mysteries.
right. So you could have 1 mystery book and the others are 2 mystery books, but as long as they're not all mystery books.
Okay.
Okay?
Yes.
All right. Oops, sorry. All right, so then Mariah's choosing 3 books to read from the following. Same question. It says, which of these statements are true? So if she's choosing 3 books, the first statement here explains she has 20 books total to choose from, and she's going to choose 3. Now, why is it a combination?
Because the order doesn't really matter of what books she chooses as long as she doesn't choose mystery books.
Very good. So this is your total possible outcomes. So those are all the different ways that she can pick 3 books. That's your total possible outcomes. So that's a true statement. Next,
Okay.
it says there are 5, choose 3 possible ways to pick 3 mystery books. So what the 5 represents is the number of mystery books you can pick from, and the 3 is how many she is going to pick. So that is true, because there are 5 mystery books to
Okay.
choose from, and she's going to pick 3.
That makes sense.
Now the next one says there are 15, choose 3 possible ways to choose 3 books that are not all mysteries. Now this is the problem, not all mysteries. It's true that these are not mysteries, but when it says not all mysteries, some of them could be mystery books. When we say all 3 books are not mystery books, that means one of them could be a mystery book, 2 of them could be a mystery book,
Just
etc.
yes.
So
Okay.
that statement is not true.
Okay.
Next, it says, what is the probability Miranda will choose 3 mystery books can be expressed like this. Now, that is incorrect because when you do probability, it has to be success over total outcomes. So how can she choose 3 mystery books? Well, she has 5 mystery books to choose from, and she could choose 3. That's her success. Divided by how many books does she have to choose from?
Um.
There were a total of 20
20.
books, and she's going to choose 3, correct?
Yes.
So that's your total outcome.
Okay.
Now, if we read this sentence again, it says not choose all books. This is your complement. Remember we talked about the complement a second ago?
Yes.
So you do 1 minus that probability. 1 minus that probability to get the complement.
Um.
So just to give you another for example, if I told you that the probability of picking a 5 on a dice was equal to 1/6, do you agree?
Yes.
Then the complement would be 1 minus 1/6, which is 5/6. So that means I have a 5 out of 6 chance of not rolling a 5.
Okay.
So that's your complement.
Okay. So does that mean that since it's a complement of this, that it will be pretty
1,
high, like pretty high out of the total if it were a percentage?
yes, it probably is very high.
Okay. So, okay. That makes sense.
Good?
Yes.
Okay. Next it says a farmer has an orchard that covers an area of 40 acres. This is that areas they're trying to get you to do probability with area. It
Okay.
says it grows apples on 25 acres, peaches on 7 acres, nectarines on 5 acres, and plums on 3 acres. So I just
Okay.
want to, let's see, that's 8, 15. So that totals your 40 acres,
Yeah.
correct? 25 plus 7 plus 5 plus 3.
Yes.
Okay. So it says the fruit trees are equally distributed within the orchard. A tree is chosen at random. Rounded to the nearest tenth of a percent, what is the theoretical probability that a tree is not, so notice here they're using the word not, which means what are we going to be looking at?
The complement.
The complement. What is the probability that the tree is not within the acres of the apple trees? So what we're going
So,
to do is take 1 minus the probability that it is in the apple orchard. So
okay.
that would be 1 minus How would I figure out the probability of being in the orchard, the apple orchards?
All 40 acres.
No, not all 40 acres are apples. How many
Oh,
are
apples. 25 acres, sorry.
out of how many?
40.
40. So that's the probability of being in the apple acres. Does that
So it
make
could be
sense?
15.
So
15 out of 40.
15 out of 40, which is equal to what?
Um,
It's saying to, I believe,
3 over 8.
yeah, round to the nearest tenth of a percent.
Oh, in percentage, let me see.
Yeah.
Point 37%, 0.5,
Right.
37.5%.
37.5%, correct.
Yeah. Can I run to get my charger for my laptop really quickly? It's a little short on battery.
Yes, that's fine. Let me go ahead and pause the video.
Okay, we'll be back in a second.
Okay. Bing. Okay. So here it says you have four numbers from a set of 0 to 9, including 0 and 9, are
Wait,
used. Pardon me?
excuse me. I'm not in the screen again.
Oh, thank you.
Sorry that I have to leave and get.
That's all right. I couldn't pause the recording unless I took you off the screen presentation. Let me know when it's back up in front of you.
Loading right now. It
Okay.
is. It's on now.
Okay. All right. So it says four numbers from a set 0 to 9, including 0 and 9, are used to create a personal identification number. Once the number is used, it cannot be used again. So what's important here is the fact that order is important.
Order. So it's a Oh, I'm drawing a blank.
Permutation.
Permutation, yeah.
So this is a permutation of n things taken r at a time. So it's n factorial divided by r factorial. Okay? So
Okay.
the first question says, how many possible outcomes exist? So how many things do I have to choose from?
9. Wait, 10. What am I saying?
You have 10 to choose from, and how many do we want to choose?
I mean, 4 numbers.
4 numbers. So that means 10 factorial divided by 4 factorial. So that's going to be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 4 times 3 times 2 times 1. Actually, I got that wrong again. It's by n minus r factorial. So it's 6 divided by 6 factorial.
Wait,
So
n minus.
r factorial.
So how do you?
So
n,
it's 10 minus 4, which is 6 factorial.
the number of possible over the desirable outcomes?
Right.
Okay.
So you get 10 times 9 times 8 times 7. So what does that equal?
90. Wait, let me get the calculator. $5,040.
Right, 5,040. So what if I switched it and said that the number has to begin with 0? Okay. So then I've got a 0 here, and then how many digits do I have left?
9.
I have 9 things, and how many more do I need?
How many more do you need?
Right, because the first one's already taken up with a 0, correct? So we're
Yeah.
saying that the identification number has to start with a 0. So then how many are left?
Mm, wouldn't it be 9?
No, I have 9 numbers left, but how many left are in the identification number? I've only taken care of the first digit. So how many
3.
more?
Wait, 3?
3. So
Okay.
what is the permutation of 9 things taken 3 at a time?
The n over n minus r.
Yes,
That would be 9 over 6. No, 9 factorial over 6 factorial.
correct.
Um, 9 times 8 times 7 times 6 times should be 36 divided by 6 times 5. It's, oh gosh, I got order of operations wrong.
You should really write it out because it's just 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 6 times 5 times 4 times 3 times 2 times 1. So this all cancels.
And canceling is just to make the equation or make it easier to solve. There's no right.
Right. Well,
Okay.
I mean, it's mathematically correct,
Okay.
but yeah.
3024.
So you took 9 times 8 times 7 and got 3,000?
Oh, I 9 times 8 times 7. 504.
504 times. All right, so then what's the theoretical probability that the ID number will begin with 0?
Theoretical. 504 over 5040.
Good. And go ahead and take that to the tenths place.
What do you mean?
What is your answer to the tenths place rather than a fraction?
0.1. What, 10%?
Yep, zero point 0.1 or 10%. Okay, do you see why order matters in this one versus the other problem?
Yes.
Okay. All right. Already did that dark problem. Okay, so this is our last one. It says
Yep.
6 students, Michelle, blah, 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 are running for identical positions on student council. So since they're identical positions, does the order matter?
No.
No, order does not matter. So this would be combinations or grouping, correct?
Yes.
What is the theoretical probability that Nadar will be chosen as part of the group? So there are 4 positions. Okay. So
One. Mm. And so, wait, I would take the sample space and times that by 1/4.
right. So out of the 6 students, how many are going to be chosen?
Only 4 of them. Wait,
Oh, only 4 of them will be chosen, correct?
yes.
So is that your total or your success?
The 4 would be the success, 6 would be total.
Well, this whole combination is your total outcomes.
Oh,
Because there are 6 students and you're taking a group of 4.
okay.
And then what is for the success is that out of the 4 students, one of them is it, do you pronounce it Nadar?
I'm not sure.
Yeah, I think it's Nadar. So that would be your success.
Success. So, would you do the n over n minus r factorial, or to find the total? Oh, let me think. Wait, 120. I can't.
I'm looking at what they put down as their answer, and it doesn't make sense to me.
Running for 4.
How many ways can you choose? Let's look at these numbers individually. So how many ways can you choose 4 people from a group of 6? So that's your, remember, n factorial over r factorial times n minus r factorial.
18.
So that's 6 factorial over 4 factorial times 2 factorial, correct?
Yes.
So that would be 6 times 5 times 4 times 3 times 2 times 1 over
About
4 times 3 times 2 times 1 times 2 times 1.
Wait, why double?
Because this is a combination, remember, so it's r factorial times n minus r factorial. So you got to factorial them both. So there are 15 different ways.
2 times 1. Oh, so, and then since it's, wait, if it's minus, you just don't put the minus, you just keep
No, n minus r. What's 6 minus 4?
2.
2. That's where this 2 came from.
Yes, okay.
Okay?
Okay.
So there's 15 different ways to pick that group. And
Okay, I guess.
then of the 4 people, we want one of them to be Nadar, right? So that would be 4 factorial over 1 factorial 3 factorial.
Okay, so when over the n minus r, you include both of them, you include uh r and n minus r when you're
Yes, it's a combination when it's a combination.
and when it's not a combination, it's just the n minus r and not n, or not r at all.
Correct.
Okay.
So that's so a combination of 4 things taken one at a time gives you 4, which is equal to, does anything say I get 4 15ths.
Let's see. 26%.
Yeah.
Or 27% if you round.
Good?
Yes.
Oh wait, I know what you know what? It wouldn't be 4 choose 1. How many people are there to choose from?
1, 2, 3, 4, 6.
6. So it should be 6 choose 1. That's where it's coming from. Should be. It won't let me pick up the eraser. There we go. So how would I write out 6 choose 1?
With the C in the center, 6 on the left, and 1 on the right.
And how would I write it out to show my work?
6 factorial over 6 factorial 5 factorial.
Over 1 factorial 5 factorial. Because this is r, and r is 1. And this is n minus r. So that's 6 times 5 times 4 times 3 times 2 times 1 over 1 times 5 times 4 times 3 times 2 times 1. So this answer is 6 over 15, which is 2/3. That's where they're getting the 2/3. 6 people to choose from.
Right.
Do you understand? If I asked you,
I just don't understand how 6/15 becomes 2/3.
you reduce them both by 3.
2.
6
What
divided by 3 is 2. 15 divided by... Oh, wait. No, it isn't 2/3, is it? Sorry, my bad. I was thinking it's 2/5.
Yeah.
2/5. All right. If I asked you to take a combination of 8 things 3 at a time, how would you set it up?
Wait, can you say that again? I didn't really get that.
Up here in the corner, do you see it? 8 things taken 3 at a time. How would you set it up? I just want to make sure you can set up the combination.
8 things taken 3 at a time. Wait, where is it in the corner?
Can you see my screen?
Yes, I can.
Are you
Sorry.
here in red? See me writing right
yeah,
over here
okay,
in red?
sorry.
Okay.
Okay. It would be, let me write it out. 8 factorial over 5 factorial 3 factorial, which would be
And
8.
really, we normally do it in the other direction. We would always put r first, so 3 factorial times
Okay.
5 factorial, but either way. Okay. So, what do you think? This last problem we already did, actually.
About the whole concept?
Yes.
I think I understand it a lot more now. I was really confused with all the factorial stuff and the difference between the combination and I always forget the name.
Permutation.
Permutation, combination and permutation, and how to set up the equations.
Okay.
I think I get it a lot more now. So,
Okay.
thank you very much.
You are very welcome. Do you have any other questions?
For now, I think I'm good. I think that helped a lot.
Okay. I'm just trying to find your folder here. Okay. So then I will go ahead and share that recording with you.
Okay.
And send that to you later tonight.
Okay.
Okay, and I hope you have a good evening.
You too. Thank you so much.
You're very welcome. Talk to you later.